Hello everyone, this video I will show our new product. This is KinCony Server-Mini version. This is a Raspberry Pi 4 8-channel relay module. It has 8-channel relay output and 8-channel digital input and some external on the PCB board. Before we have released this KC868 server. And this board is big and this is small one, so this we call mini version. But maybe you will ask me what's the difference between these two boards. So this time we have designed this board as easy for user to use because we have connected the relay output and the digital input to this CM4 GPIOs directly. So without external chip, just directly, so that you will very easy to use the Node-RED, use the Home Assistant, or write the Linux computer software program very easily to use by this code, because all is GPIO directly to driver the output and the input, so that you can do anything, any logic code from this board. Okay, let's look at the hardware details of this board. Okay, let's look at this hardware details about this Server-Mini version. You can see this is our PCB board. This time we have designed this PCB used by the color black. So you can see this in front and this is the back. Okay, we can see this in front of this board. There are many interfaces, and you can see that is 8-channel relay output. That is supported relay is 10 ampere, and every channel that have COM, normal open and normal close. So every relay have 3 pins, and the common, normal open and normal close. And this you can see I2C extend. This socket also is removable. So you can see this is I2C, and this is the power LED and the CM4 Raspberry Pi work state. And also you can see this is for the Raspberry Pi. If you have installed the Raspberry Pi, you can see just use this way. And here you can see that is have some extend on the PCB board and I2C and SPI bus. And here we can see that is the power 12 to 24 volt for this power supply, and the digital input just for 8-channel digital input, and this is the IS485 interface. And you can see that have 4 USB sockets. You can use by the USB keyboard and USB mouse or USB device or USB Zigbee dongle and any USB device SD card. And this is for the USB Type-C. That is for download the firmware for the CM4. And this is the HDMI. The HDMI is used for the monitor. You can connect to your computer monitor directly. And this is SD card, because if you use CM4 without eMMC, you can use the SD card. So you can see this board, the CM4 is without eMMC, so you can see that can use the SD card. Just insert the card as this way. And you can see that is the Ethernet for LAN network cable. So, and this have a jump. If you want to download the firmware to the SD card or to eMMC, you just move to the left. If you want the system start up with the SD card or eMMC, just turn the right. So this is for the boot options, the jump. So you can see this is my board without CM4. And this I have a board installed the CM4. You can install the different CM4 module to this board. So you can see I have this CM4 new module. This have the eMMC. So you can see I can and this is a new CM4 module. And here you can see that have a eMMC chip on the board. You can see this board is without eMMC. So if without eMMC, you need to use the SD card. If this board have eMMC inside, you not need to use this SD card. You can't use the SD card. So you can install this module on this socket, just at here directly. And when you begin running, so that you can install this heat link, you can see here, you need to stick this on this CPU because it's hot, and you need to install this heat link. So you will see your board will become beautiful, just will be this way. You can see here will be this way, but you need to fix by this screw for this heat link, and this to fix. Okay, this is a Raspberry Pi. And also we have designed this box for a practical shoe. You can see here, this is our shoe, and support install on the DIN rail. So you can see I can and this is inside, and you can put your board, PCB board, on this plastic shoe. You can see this is in front, and this another side. So this is a plastic shoe. You can install by this way, and you can stick your label. Maybe you can print your logo of your company and put anything on this stick. So you can see here this side and this side. Okay, this is the plastic shoe of this board. And also we are designing, you can see here that have a metal cover. We have designed this metal cover just on the design for this server board. So you can see this is this one side, and this another side, and this metal cover will be used by black color. So that will be beautiful. And this is size of the top layer and the size, and we will print by the laser, and the label print on the metal box. So we'll print on it, and with the pin define, and with the brand and the product name, and this every pin define and print on the metal box. So this is our design, and we'll release it in future for this new cover. And also let's look at the PCB design. This is for the Server-Mini, and we can see the 3D version, and also we can see at the back, you can see this is for high voltage. So you can see there are no any circuit, and this is for the low voltage signal voltage of work at this layer. So this is independently for the stable reason. So this is the PCB, and also these are open source. You can download the schematic, and the schematic you can see, you can download it here, that KinCony website, and the software document. You can click, and you will see this whole board schematic. We are open source for our KinCony board. So we have told you that this time we have designed the Raspberry Pi. Just the input and the output have connected to the CM4 directly. So that will be easy to program and use in Home Assistant. So you can see there are no any other chips, just connect to this input and output directly. We can check in the schematic. You can see this is CM4 pins, and you can see it here. This is CM4 pins, and this is output. You can see that CM4 IO4 and connect to output out 4. This is out 4. You can see the out 4 have connected the chip ULN2003. That is the driver for the relay. So only the hardware driver for the relay, no any other chips. So you can see the different IOs pins have connected with the different output. This output just directly connect to the driver. So you can see the driver have connected to the relay. So this is the relay. So you can use the GPIO, CM4 GPIO, control it directly for the relay output and the digital input. And here is power circuit. This is power. And for 33RF receiver, you can use the remote. And this is output, and this is input. And the input is used by this way, so that can for long distance. And this is the main Raspberry Pi 4 circuit. Okay, you can download from our website and check some details. And also you can see many results on our form. You can see that have the hardware interface and results. Just click, and this PDF file, just this file. So you can see every pin defined and what function you have used. And also you can see here that have Raspberry Pi 4 GPIO defined. So you can see here that is all CM4 GPIO for output, for input, and for RF receive module, and for I2C. SPI bus, this is I2C. So you can use a node-RED, maybe you use Home Assistant, just according to this table. And back. And also you can see we have designed the Python demo code. You can see here, I can click. You can test all the hardware results by this Python code. And use the test remote, and test the digital input, and test the USB device where it works well, and HDMI for the monitor. So this is for testing your hardware where it works well. And then next, you can see that is used by the node-RED. We have designed this diagram, and all nodes you can see will be very easy controlling 8-channel relay and the digital input on the web page. You can use the web page on your PC or by your mobile phone. And because the Raspberry Pi, you can try out the Raspberry Pi node, so that will be very easy to control the output and control the input. Just select the GPIOs. Okay, let's have a demo. We will use this board, work with Raspberry Pi OS, and connect with this monitor. So you can see here I have a SD card. The SD card I have installed Raspberry Pi OS, so I can insert to this socket, and I connect with the Ethernet cable. I connect with the Ethernet cable is stable, and this is HDMI. This is HDMI, and for this monitor, and this is 12-volt power supply. I will connect at this terminal. So you can see when I connect with it, the power LED is on, and the CM4 is blink LED. That is begin work. And you will see this monitor is begin start up. So you can see this mouse and this Raspberry Pi OS. Okay, the next we will connect with the USB device because we have the USB cable, keyboard, and the USB mouse. So this I have used the Bluetooth. So the USB mouse and the keyboard used by this Bluetooth adapter. So I will connect to the USB port. So you can see here, I have connected it. And you will see my mouse can move. So you can see I can use this and open the menu. So you can see here. Now I will open the Node-RED. So you can see I have already installed the Node-RED. So I just input Node-RED to start service. Okay, it starts. And now you can see I can open the Node-RED. This is IP address of our board. And you will see that the Node-RED is opened. And this node you can download from our form. So you can see the code you can download it here. So we can see this already have download. That is for the output, relay output. And this is for the input. So this will be very easy. Just input, constrain this output, and the relay constrained by the web page. So you can see here, that is our web page demo. You can see I can turn on relay 1. That the red LED is indicate 1, 2, 3, 4, 5, 6, 7, 8. So this 8 relay will be on at this board. And also I can turn off. So you can see I can use my cable. I short for this is ground and this is input 1. And you can see here the input 1 state is changed. State is changed. And the input 2 changed when I use the input. Short for the track of the output. And also I can see the state on the web page. This is 3. So this is very easy, set by the Node-RED. You can see here, the Node-RED, because the Node-RED have the Raspberry Pi node, so that will be very easy use for the in and the out. So you can see, we can double click for this input. This input 1, that is GPIO 18. Why use GPIO 18? You can see here, because the input 1, we can choose this input 1. You can see here that is GPIO 18. So you just choose such as input 2 and input 3 and input 4 and corresponding the GPIO for the CM4. So you can see this is for input 1. You can see this is relay 1. This relay 1 we can double click. You can see that is GPIO 5. So why choose the GPIO 5? You can also see here that is output 1, just means relay 1. That you can see this is GPIO 5. So if you want use the relay 2, relay 3, relay 4, you can see the out 2, that is GPIO 22. So you can see here, that is 22. This is relay 2. So you just dry out, so you can see, just dry out and set the GPIO number for this node. Click and set a number for the GPIO. You will use this output, and this is for input. So this is very easy to use by the Node-RED, because we have designed this board use the GPIO device directly. Next, let's look at this board. If you integrate to Home Assistant by the Raspberry Pi GPIO directly, that also will be very easy. This is for binary sensor, just for digital input. You just use this code. This is plant 4, just choose the Raspberry Pi GPIO. And this is the IP address of your board. And this is ports, which GPIO you have used. So that will be very easy. Just this simple line for define the binary sensor. Also, you can see the switch also is very easy. Just this code, plant 4, and the IP address of your board, and the number of the GPIO of the CM4 of the relay. So will be very easy. Just this simple command you can configure for your Raspberry Pi for Home Assistant. Okay, thanks for watching.